very good morning to one and all present here. The HOD of IT department, Dr. Ashish Jadhav sir, faculty members and all the participants present today. I welcome you to the fourth day of this summer internship program, SIP 2020. Before we begin today's session, I have a story to share with you based on the idea of positive thinking and never give up attitude. So once, a young schoolboy was caught in a fire accident in his school, and it was assumed that he would not live. His mother was told that he was sure to die, for the terrible fire had devastated the lower half of his body. Even if he were to survive, he would be a cripple throughout his life. But the brave boy did not want to die, nor did he want to be a cripple. To the amazement of the doctor, he did survive. But unfortunately, from the waist down, he had no motor ability. His thin leg just dangled there, lifeless. Ultimately, he was discharged from the hospital, but his determination to walk was indomitable. At home, when he was not in bed, he was confined to a wheelchair. One day, he threw himself from the chair, pulled himself across the grass, dragging his legs behind him. He reached the picket fence, raised himself up, and then, stake by stake, he began dragging himself along the fence, his resolve to walk undeterred. He did this every day with the faith in himself that he would be able to walk one day without the help of anyone else. With his iron persistence and his resolute determination, he did develop the ability to stand up, then slowly to walk haltingly, and then to walk by himself, and finally he began to run. So what happened after? He began to walk to school. Then he began running to school, and then to run for the sheer joy of running, later in the college he made to the track team. In February 1934, in New York City's famous Madison Square Garden, this young man who was not expected to survive, who would surely never walk, who could never hope to run, this determined young man, Dr. Glenn Cunningham, ran the world's fastest mile, an epitome of the power of positive thinking and faith in oneself. Glenn Cunningham continues to be an inspiration for many, and his story, a brilliant testimony to how one can bounce back even when all the odds are stacked against one, to the extent that death seems the preferable option. We should all take motivation from Glenn's story today and work hard. We should work hard every day for the rest of our lives. Now, I would like to call my co-host, Ms. Ritvika Sanath, to continue with the session.
The will to win, the desire to succeed, the urge to reach your full potential. These are the things that will unlock the door to personal excellence, said Confucius. Good morning, everyone. I am Ritvika Sanath, and I'd like to welcome you all to the fourth day of Summer Internship Program SIP 2020. I hope you all are in good health. Today, we have a speaker with us who needs no introduction. His poems and posts inspire us to ponder upon self, while his teaching makes us powerful to solve all the problems around us. Please welcome Mr. Madhav Vyas for his session on functions. Over to you, sir.
Good morning, everyone. Well, thank you so much, Abhijit and Ritvika, for starting the session on such a positive note. And I'm very happy to see the excitement among the students. Good morning again, everyone. I am Madhav Vyas. As Ritvika introduced me, I write. And I write basically whatever is going on in my mind, or things that others even can read, and try to ponder upon the deep realities of life. Not the sad ones, but on every aspect. And starting on a positive and a happy note this morning, I'm just very much, I'm trying to recall my first year days of engineering. So it's a nostalgic feel for me right now, because I've been teaching Python for more than a couple of years now, and as well as Java. So for me to go back to C is really nostalgic. I can recall my first year engineering days. And also when I take this session today, I feel it's a big responsibility on me to ensure that the interest is fired up among the first year students. So basically, I have three categories of students right now for today's session. One category who will be in the zone of I know about everything related to C. The second category would probably be okay. I remember some of them. Maybe when I look at them, I'll be able to recall everything. And the third category would be like although you have studied C, but since it was the first time, maybe some of you have been exposed to programming. So a little bit of more drilling would be required to have some confidence, some good base while we start today's session. So I had run a poll yesterday just to get some brief of my audience. How many of you would like to go me into the basics of functions, the theory behind it, how a function is to be written, what are the different concepts associated with it. And the kind of response that I got, I would like to say that I have made it a mix of theory as well as programming, so that not only we learn how to swim, we also know the direction in which we are supposed to swim. And I'm very happy the kind of response the students, the kind of interaction that I could hear right now. I can recall some of the names as Aftab, Vedant, and I think someone else. If I'm missing out, I think I'm missing out a name. But anyways, I'm very happy to know the kind of audience that I have for today's session, and I really hope that you'll be able to learn something new. And I can ensure one thing: after today's session, there will be no stone untouched that you'll not be able to discuss about functions. So any place you go, any kind of competition that you see, all the concepts will be covered in today's session. So what I've planned is we will have approximately 2 sessions. The first session of around 40-45 minutes, so that whatever I'll be showing you right now, all that you can absorb with a short break that will be taking after that. And also there will be something interesting that I'm sure Abhijit has planned, and some surprise from my end as well. And thereafter we will move on for the next session. So in this, I'll be covering the basic theory, the programs of all the concepts those are associated. Also, some comparative coding will be included in this session. Fine. So I would request that each and every one of you pay attention to all the things those are being discussed. Some of you might already be knowing it, but it is always good to have a second look or a different perspective when someone is trying to throw light on some topic. So I'm really happy to have an audience like all of you from the kind of conversation that I could hear. All right. So I think we can start with this session now. Are we waiting for any more participants to join, or can we start?
Sir, we can start the session.
All right. Okay. Thank you so much.
Thank you, sir.
Okay, I just see the confirmation my screen is visible.
Yes, sir, your screen is visible now.
Okay, all right. Okay, so a common request that we make every day, please keep your video on off and mute yourself. I know we are all sitting in really bad weather, even at my
sorry
place.
to interrupt, sir. I think you will have to present again.
Okay.
I think somebody else just clicked on presentation, so somebody else started the presentation.
Oh, okay.
So it is a request for everyone to please not to click on present now.
All right. So requesting you all to please keep your video off, mute yourself, and also please do not click on screen share. So we have reached this far. We have reached to the topic of functions today. You already have covered C programming basics, a wonderful session on pointers by Pallavi ma'am. And so here we are today. So basically, we can see these two styles of programming. On the first, on the left-hand side, you can see a complete program is written inside your main function. These lines are just to represent that an entire code has been written inside the main function. So such kind of a programming is known as monolithic programming, wherein the entire program has been written inside the main function. On the right hand side, you see at the bottom there is a main function created, and there are two calls, function 1 and function 2. So what these functions are, how do they work actually, we will see that. But basically, I just wanted to tell you there are two styles of programming. One is monolithic and the other one is modular or procedural, where we break the code into different modules, into different parts. So that is the objective of today's session, how to break your code smartly into different parts. What are the various ways in which you can break your code? What are the different properties that you need to understand? How do we break our code and what all rights do we have while breaking the code? All right. So this is a snapshot of a normal C program wherein you see a normal main method has been created, a main function has been created rather, because we are in C, so we will strictly talk about functions. And inside the main function, you see 3 variables have been created. Now in this main part, you see a call has been given to the add function. An add function has been called from this part of the code, and all the details of that function is stored in a variable that is Z over here for us. All right. So this kind of a function, this kind of a code that you see can be divided into different parts to understand what exactly do we mean by function. So we will start one by one. So the thing that you see on the top statement as over here is just a prototype. For example, if I write a data type and a name by which I want to create a function, and some parameters if I want to pass some values in it. So that will just build a prototype for me. Even if I do not give the details of how exactly the function will work, what all manipulations will happen in it, if I simply write down the data type, the function name, some parameters maybe, and open and close the brackets. So that will just build the prototype for me. Thereafter, if I write the details, okay, what will be happening inside the function? There will be some variable C. That variable C will be storing the summation or the addition of 2 variables A and B, and will be returning that value C. So now you are giving some life to it. You are passing a soul to the body that was just created. So that soul is your function definition over here. All right. And how do we connect to that soul? We have to call. We have to call. So how do we call that? We actually write the function name and pass some arguments. Now these arguments are in correspondence with the parameters that you see over here. Integer A and B will be in correspondence to the arguments X and Y that you see over here. All right. So in order to access the function's capabilities, the properties, we have to give it a call. How do we give it a call? We have to write down the function name and all the details. Maybe we can pass it to some variable. So now this Z variable holds all the information about the function add for us. So this is known as calling the function. The next thing, as I call the function add, I am specifying 2 things, X and Y. So the variable X and Y are known as actual parameters, which are coming from the main function. All right. So these are acting like some global variables for us over here in this case. So actual parameters are the parameters or the variables or the entities which are passed through the main function to some function which is lying outside the scope of main function. So these are actual parameters. Also, we have formal parameters, which are the parameters or the entities or the variables which are part of some function which is outside the scope of main function. Okay. Now, there are some more properties that we will be seeing which are associated with functions, but it is important to remember that while we speak about functions, we have a main function which is necessary for us to run the program in C, and also we have an optional function that we can create on our own depending on the requirement that we have. Now, why do we really need to create functions in a single code? That could be due to various reasons. Consider a scenario wherein a manager has given a work divided such a way that he has 4 members in his team, and each member has been given certain task to be done. Now that task, you can assume it to be a function, some functionality of an application, so that the manager can divide the code efficiently or the task efficiently among 4 people by assigning each function to each individual. Also, whenever the entire function, the entire set of function will be collected, collaborated together, the manager will exactly know, okay, which functionality has been developed by whom. In case if I encounter an error, which individual has to be called upon. to get an answer from him or try to study the code that has been given by an individual. This makes the production environment much more optimized because the manager exactly knows he has divided a task equally into 4 people, and in case if something goes wrong, which person has to be held accountable for that. Okay, so I hope that thing was clear to you. Now I want to tell you exactly how things work internally inside the memory. As we proceed for this part of the code, I would like to make an announcement for everyone. The topics of the functions I have not displayed as an index so that you already do not become biased towards it. Okay, what all things will be taught in which manner. I'll be connecting dots bit by bit so that at the end of the session, the bigger picture will be clear to you. You'll be able to understand why did we start from a certain dot and where we have reached right now, what was the objective. Still, in case if you have any doubts, you can mention in the chat window, and I will not interrupt the session in the first 40 minutes. The reason being we are on online platform right now, and in case if someone asks a doubt and I'm trying to answer that, even a lag of 30 seconds or a minute may distract the rest of the audience in the ongoing session. So the break that we have after the 40 minutes, you may write down your question on your notebook or you may simply post it in the chat window. I'll be able to answer them, all of them. And by the time we already have our volunteers will be trying to chat you, to answer you through the chat window. All right. In case if something is really important, critical, in that case, you may unmute yourself and ask. So that should be rare, I believe. If that is really something without which we should not proceed. In that case, you may mute. All right, moving ahead, how does a function get stored internally? So whenever we write a code, that code gets stored inside our main memory. So there is a code section in which, for example, just the previous program that we have seen, it had the main function as well as the add function to add 2 variables and return the result to us. So whatever code we are writing gets stored inside the code section of our main memory. All right. So as this code is run, as we compile this code, we tend to create 2 variables. So those variables x and y, if you remember in the previous case, I would like to show x and y, these are the actual parameters. So the actual parameters are from the main function. So these get stored inside the stack. So stack is usually not just, it is not just above the code section. We have other sections also, and above them we have stack. So just for the simplicity's sake, I am representing stack just above the code section. So you can see x and y is storing the value 5 and 7 respectively. Now we will not look upon z at the moment because I am assuming that we are still in the part where we are just compiling the code, and in the stack section we have created a space for variable x and y which are holding the value 5 and 7 from the main function. Now when we give a call to the add function, when I give a call to the add function, from here the call is passed on to the add function. At that point of time, we tend to create another set of variables a and b, which will hold the values 5 and 7 respectively. Okay, so a and b are holding the values 5 and 7 respectively. So this is inside this stack space, a separate zone being created for this add function, which we are running right now, which we have just called right now. And in the same add function, what we are also doing is we are manipulating, we are adding the values of a and b and storing it in the variable c. Now when the value is stored inside the c, that same copy is passed to the variable z. Now the variable z stores the value 12. So we are getting the value in z because we are returning the value of c. So when we are returning the value of z, now z contains all the information, and when we print it, we actually show it to the person who is a user, let's say for us, and the value is passed from c to z, and the same value 12 is copied to z as well over here. Now once this task has been done, the task of the function has been done, uski responsibility khatam ho gayi, we will scrap off this space that was utilized by the add function. So this was a temporary space consumed by the add function that we scrap off once the functionality part associated with that function has been completed for us. Okay, so this will be there in the memory. It will be there in the memory. It is associated with the main memory part. These are also known as actual parameters. So, an actual parameters will not be getting affected in a usual case when you try to call it through some, by a call when you try to connect to some other function like add. In this case, in that case, whatever is the value of x and y, that will be retained as the actual parameters value. Now the formal parameters may change. So the formal parameters, you can call it as a temporary thing which may get changed and which will be destroyed once the task has been achieved. So just to visualize the things once again, as the values pass from C to Z, that stack space is destroyed. So we are inside the stack memory. The first part is the code section. Above that we have stack memory. Inside stack we have x and y variable, which are the actual parameters. And then we have formal parameters inside the add function. Once the value from C to Z is passed as 12, the stack memory of the add function will be deleted. Now another thing that I want to inform you, both the function cannot access each other's variable. The main cannot access add's variable and vice versa. Add function cannot access the main function's variable directly. There are certain manipulations possible that we will see in the coming section. I hope things so far are clear. There is no major doubt. Coming on to the definitions part now, I hope the things function is clear to you. Why it is created? It is created to ensure modularity, to break your code into definite parts, to assign tasks properly to different individuals who are responsible for that function, and also for efficient debugging. So they are also known as procedures as well as subroutines. They are used to divide a large number of programs into smaller parts. It can be called multiple times to provide reusability and modularity, and rewriting can be avoided when we create functions. So whatever we discussed initially has been summed up through these points. I hope the things are clear to you. You have been able to absorb all these points. Abhijit, let me know in case if there is something important because of which I need to stop and clear the doubt.
Okay, sir.
Fine. Thank you. Okay, the next set of points about function. So as we have already discussed, the debugging becomes easy. Now the function can be either of the three states. Either it is being declared, that is just the prototype that we have just seen, or it can be in the definition stage where the soul has been given, the functionality associated with the function has been given, and the third state, when we are trying to execute the function, we are trying to derive the information out of it. In that case, we usually term it as a call. So declaration, definition, and call, three stages. Declaration and when it is created, definition when we want to execute, and call is when we want the function to be executed whenever it is called. Now it is to be called in the same order as we want it to get executed. That has to be taken care of. Now usually there are two types of functions, library and user defined. Library are those which are system inbuilt that we usually use for the basic purposes. For example, if I'm using printf, which is an inbuilt function, and a user defined function can be something as we have just seen, creating an add function to add two numbers. Now the first set of programs that we will be seeing will be focusing on these parameters, that is the actual parameter and formal parameters. We already know by now what are actual parameters. We have seen that through a code. When a function is called, the values which are passed in the call through the main function are known as actual parameters, or the arguments as well. They are also known as argument. And when we only say parameter, it could also mean a formal parameter which is local to the variable, to the function from where it is associated with. Okay, so actual would mean from the main function, formal would mean from the function which is outside the scope of main function. Example, copying from a friend in exam. In this case, you all could be able to relate, I believe. For example, if you're trying to copy from a friend, let's say your friend is writing some answer perfectly for a question which has been asked for 10 marks. Now that friend has written something, let's say a matter of 2 pages covering 10 points. When you are copying from that friend, it could be a case that now you are making that answer of 2 pages into an answer of 3 or 4 pages, and you have converted those 10 points to 20 points, right? That could be a scenario. It is also a possibility that you will score much more than your friend. Okay, now in this scenario, what is happening is your friend has actually delivered you certain content. Now that content you cannot change. That content you cannot change. That is the actual parameter. What you can change is the formal parameter that is associated locally with you. Also assume there could be some other person who is also copying from that same friend. Now that other person, what he can do is maybe he can reduce that answer that has been written on 2 pages to a page, and maybe he can bring down those 10 points to just 3 points. Again, it is his own version. In that case as well, he is not actually manipulating the actual parameter, the information given by the main function, the main supplier of the information, that is your friend who may be the topper of the class. Okay, so I hope with this the thing is clear how to differentiate between formal and actual parameter. You cannot change the actual parameter directly. There are ways which we will study later, but for now just understand actual parameters cannot be changed. The original information is retained in them. What you can change is the formal parameters by taking the actual parameters as an argument. Okay, now we have 4 methods of function with respect to argument and return type. There are 4 ways in which we can pass argument and in which way we can get some return values from the function. Argument, by now you know they are actual parameters, and return type is something which a function is giving as as a summary of information and as a last statement or the last piece of information whenever that function's execution is about to complete. The first case is we can have a function which does not have any argument, and also it does not have a return type. It is absolutely not necessary for a function to have an argument compulsory or a return type compulsory. Now there could be another case where we have an argument but we do not have a return type. Another case could be without argument but we have a return type. We are not passing any argument but we have a return type information. The last case could be we have an argument, also we have a return type. Now the return type, just to remind you all, return type is associated with the data type of the function. If the function has been declared such that integer space add or int space add, we know that whenever this function will be returning something, it will be in the form of integers. If the function does not have anything to return, you can leave it blank, or maybe you can specify void. Right. So we will see all those codes one by one now. Okay. I've chosen Visual Studio Code for this session. I'll just briefly introduce the important parts of this. Now, this is an IDE, an Integrated Development Environment. IDE stands for. This is useful for coders to create an environment of quick coding. How we can use this as beneficial element for us whenever we try to code something, whatever are the associated spaces, tabs or suggestions, all that we can get through an IDE if that IDE is compatible with your programming language that we are using. Now the Visual Studio Code does not have a compiler inbuilt. We have to assign it, or we have to connect the extension of any programming language that we want to use. Let it be C, Java or Python. In this case, since we are using C, so I had to connect the C compiler with the Visual Studio Code. At the beginner level, why IDE is not introduced to you? Because it gives you suggestions initially. So as a beginner, it is not a good practice to already get recommendation suggestions while you're learning it. So in that case, you'll not be able to give enough exercise to your brain. But since we are progressing from the beginner to the advanced level, so I thought it's good to introduce you to this IDE as well. How does it function? So the properties which are also useful for us is that we can create a project or a folder in which we can have all the files which are relevant to us inside single space. So even if there are connections between multiple files, that is much more easy for us to see, locate it, and build a proper project out of it. so that you will see in the coming time. I'm sure you'll be building some great projects. So in that case, definitely you'll be using some or the other IDE. Now, I've just created a folder over here by the name Madhav function, and I've created all the files inside this folder. I can create a new file from this option. If I click on this and I get the option of, let's say, typing the name, I also have to specify the extension. Let's say it is sample C, something that I just want to create. And for now, we are not using it since we already have our file created with us. Okay. So here we have a few functions. Those are those you can see over here. The files are separated in different tabs. Those are visible to us. And just below this code, you have a space which is known as terminal. So in case if I want to create a new terminal, if you're using it for the first time, you go on terminal, click on new terminal. So it opens a new shell for you, a programming shell where you can compile and run your file how you usually do in your C Studio, whichever you have used so far. So in case if I want to run this file which I've just created over here, what I need to write is, I need to write GCC, the name of the file is visible here with arg no return dot C. So if I write this and I click on enter, execute this, I can get the results over here. I can also lift this up to give you a better view. The next thing is I write A and I can press tab to auto complete this run statement, that is ./a.exe. Now you can see as I am just try to compile with arg no return.c file, an executable file a.exe is created over here. So once that is created, if I hit enter, it is displaying me some output. Now it is displaying some set of stars which are which was the objective of the function. Okay, all right. So we will start with the first program that we wanted to discuss in this session. The first program that we wanted to discuss was the case where we do not have any argument or any return type. I'll just scroll this. Okay, I hope it is visible to everyone.
Yes, sir.
Okay, so this is a normal program wherein we have a main function. Inside the main function, there is nothing but a call to a function which is blank. I can identify this is a call. It is mentioning some name, and there is the function parenthesis and semicolon thereafter. So as I hit enter, the compiler will start looking for the blank function which it can find over here. Now inside this blank function, there is a print statement. That is, I'm a blank function with no return statement and no argument. I can see just before the function name, there is a data type as void. It does not have any integer, double float, or any other data type. There is void mentioned over here. So it means it will not return anything. So it does not have any argument inside the blank function. For example, if I write x and y, let's say integer x and y, I am creating two parameters over here. So I am trying to create two parameters over here. It means that whenever this function will be called again over here, there would be a requirement of two arguments which have to be passed from the main function. Since it does not have any parameters, in the blank function, also it does not have any argument in the blank call, I can say that this is a function which does not have any argument. And also I can see that this function is not returning anything. It does not have any data type assigned. So I can say it is a function with no argument and no return type. In case if I simply want to run this function, what I can do is I can come over here, the same process, GCC. Compile this, an executable file gets created, can be divided into three branches, 3 and 2. Similarly, 3 over here can be divided into two branches, 2 and 1. Now, in the case of recursive call, what happens is if you have to calculate the factorial of 5, it will go on to the value of 4, it will go on to the value of 3. अब 3 के फैक्टोरियल में क्या आएगा 2 into 1 आएगा, 4 के फैक्टोरियल में क्या आएगा 3 into 2 आएगा. अब आप देख रहे हो in this case 5 has to visit 3 twice, it has to visit in this case also. तो हम लोग यहाँ पर क्या कर रहे हैं, हम लोग एक्चुअली मेमोरी को वेस्ट कर रहे हैं बाय डबल यूटिलाइजेशन. इट मे एक्चुअली slower down the code for us. If it's a small program, in that case it is beneficial to us. Now imagine factorial of a number as big as let's say 999. तो अब जैसे 5 जैसे नंबर के केस में भी जो नंबर 3 है 2 बार विजिट हो गया, जो नंबर 2 है 2 बार विजिट हो गया. So bigger number or some other complex calculation where we have to recursively visit those numbers. Assume, just imagine the kind of pressure that we are putting on the memory. So that is a drawback with recursive function. So in that case, we have to go for a different iterative approach that we will discuss in the coming section. I hope this part was clear. What could be a recursive function? We have seen that, right? How to calculate a factorial of any number. So this is the drawback of a recursive kind of function that we usually see while we're calculating a factorial of any number. Okay, now moving on to the next topic, for which again we will see a code shortly, a program shortly based on this topic. There are two types of function calls in C based on how we specify our parameter. हम पैरामीटर में वैल्यूज किस तरीके के पास करने वाले हैं उसके हिसाब से हम लोग फंक्शन कॉल को ब्रॉडली दो कैटेगरीज में डिवाइड करते हैं. वन इज कॉल बाय वैल्यू, in which the value of the arguments are being copied into the formal parameter. अभी तक हम लोगों ने जितने भी प्रोग्राम देखे, we have seen while calling a function from the main function, let's say there was a function add inside the main function. So while calling the function add, I am passing two values. Now those two values are actually the arguments, the actual parameters, and where it is being passed, it is passed to the add function. Now the function add has two parameters expected. It is expecting two arguments to be passed to its parameters. Now those parameters associated with add function are formal parameters. Okay, so when we pass a value straight away, that is known as call by value, the very first case. Okay, in this case I've already given you an example of a student copying from another student. Inside this, only the parameter inside the function may change, while the original values will remain unchanged. मैंने example दिया था, you are copying from a friend, जो आपका friend है, that is the actual parameter. Okay, he is passing all his information, all his values written on his paper to you. Now that value you are accepting as a parameter inside the another function. Now you may change those values. Now that value that you are getting or the information that you are getting is being passed on as it is to you. Okay, without any information of the address or any other details that we will see in the next part. Now the next part is call by address. You can either pass on the information in the form of value as it is directly, or you can pass the address where the information is stored. So you can, for example, if I've got certain tasks, I have to get notes from a person. Let's say I'm a new admission in the college and I do not know from whom to get the information. So maybe I'll visit my class counselor. From whom can I get notes if I'm a new admission? I have to cover the content which have been covered so far. I missed some lectures initially. So in that case, what my class counselor would do is maybe she will tell me a roll number, or maybe she will give me a mobile number of a student whom I can contact and get the information. Now that mobile number is an address to me. I can reach out to this address and then get the information. So that is call by address in this case. Over here, what we do is we pass the arguments to a function by copying the address of the argument. Okay. Now we will see what is this case of call by address. Now there is a certain concept which I want to clear at this point. We have seen what is call by value, passing the numerical value of, let's say, A and B, if it is 5 and 7 as it is. The next case is passing the address. How do we pass the address? That we will see the program just after this. So call by value, call by address, fine. There is another term, call by reference. So when we are talking about C, we should only restrict ourselves to call by address. When we say call by reference, It is actually a term associated with C++. So when someone says the two types of function calls in C based on parameter, you should restrict yourself to call by value and call by address. We have developed a habit of calling it call by reference as a general term. But speaking syntactically or formally, it should only be call by address. Because if I say call by reference, I'm moving towards C++, which is a different concept of passing the address value through a reference. So that for that as well, I'll show you a code at the end of the session. For now, let us just focus on call by value, call by address. No call by reference at this point of time. Okay, so we have already seen how to pass the values. So in this case, since integer a and b were holding values 5 and 7, and I was passing them to the function sum through passing the variable a and b. So I'm directly passing the value 5 and 7 to a and b, which they are holding. Now, if I move on from this call by value to call by address, I have to pass their memory location. Now here comes the concept of pointer, which you already have studied yesterday. What does pointer do for us is, pointer will store the information for us of the address of any variable that we are interested in. For example, if I'm interested in knowing, assume that there is a variable a. Now there is a variable a which I'm interested in knowing the memory location. Let's say this variable a is holding some value 5, and there is some variable b which is interested in knowing the location of this variable a. It is not interested at the moment in knowing the value inside it. It is interested in knowing the address of this. Let's say it is some OO, B, C, H, and let's say 3 or something, 3, 5, something like this. Memory space is actually used. The number may not be very clear to you, but just to represent, there is a variable b which is interested in knowing the address of variable a where it is stored. So if it has got the address of variable a, it can access the value which is stored inside a. Also, it can manipulate the value which is stored inside the variable a. Now that is possible when you create a variable which is known as a pointer, which is nothing but a variable pointing to the memory location of another variable. Now this we usually denote with an asterisk sign. If I'm writing integers asterisk x, it means that x is a pointer. Now what will this point to? It depends what is the argument passed. The argument passed over here is variable a. I also see an ampersand sign, which means I'm passing the memory location of a to the pointer variable x. So now this already you know, I will not spend much time on it. We will quickly move to see how to pass the values of the function. I believe already you might have seen this because you've studied the concept of pointer, but since we are studying the topic functions, which also has the concept of call by address, so we have to study this. So we have a variable a which is storing 20 and variable b which is storing 30. I'm printing those values, and also I'm calling a function interchange. This interchange is basically swap the values of a and b through the manipulation of using a temporary variable, right? So we'll see what it is doing. But what I'm doing is I'm passing the argument a and b as the address of a and the address of b. So when I pass address of a and address of b, in order to receive those address, it is important that the variable that is created here is of type pointer. So star x star y or asterisk, whatever you call. They are ready to receive some address information with this notation. Now when that value is passed, the value that is stored inside x is actually passed on to the variable temporary. Now what we are doing over here is we are writing asterisk x and passing the information to the variable temp. We are dereferencing. In this case, what we are doing is we are dereferencing. By dereferencing, what I mean is when I write integer star s, integer star y and pass the values ampersand a, ampersand b, we are simply passing the memory information, the address information to x and y. Now when I write star x it means I'm now interested in the value. It means now I want to see actually what is inside this if I write this. So this is known as dereferencing. So when I dereference, it means now I can simply pass on the actual information to temp. If I do not write star, it means I'm passing the memory location to temporary variable. If I do not write star, it means I'm passing the memory location to temporary variable, which will not be useful for us in this case, because we are interested in knowing what is the actual value stored in variable A, which is now available to us because of this pointer variable. So I'm passing the value of x, we are dereferencing it to temporary variable. Similarly, now we are passing the actual information inside the y, not the address. We are dereferencing y, passing the information to x. Similarly, we are passing now the temporary information variable to y. So we are simply just swapping the numbers. X temp में चला गया, तो x में क्या आ गया, y की value. And now from the temp, which actually has the value of x, we are passing it to y. And now I want the interchange value to be printed over here. So in this case, what I can do is I can compile the code again. I will have to write the function name, which the program name that I've just created. And once that is done, I can see two print statements. The value of A and B are 20 and 30. So this was the first statement. The value of A and B after calling the function is 30 and 20. So we have actually called the function after the statement, which has led to the interchange of values, and then we are printing the values of A and B respectively after interchanging those values. So now you can see a case over here. I said you the formal parameter, the actual parameters and the formal parameters cannot access each other's value directly. I said you we can access it indirectly, which we will see later on. So this is the case where I am passing the actual address location as an argument to your formal parameter, and then in that case, it has got the right to make manipulation. Okay. We will move on to the next case. Okay, we are checking another case over here, where what we are doing is we again are making use of call by address. In this case, we have created inside the main function two variables A and B. We are printing those values, and we are calling the function manipulate. So we are giving a call to manipulate function, in which we are passing again the address of A and B respectively. In this case, we are changing the values of x and y such that the variable x, it is now you can see star x and star y. It means we are dereferencing. So star x divided by star y. It means that I am dividing the value which is stored in x by the value which is stored in y, not the address division, because we are dereferencing, and that information will be stored inside the variable x. Similarly, we are dividing now the value which is stored in x, we are multiplying that to the value which is stored in y, and that we are storing to the variable y, and thereafter we are making a print statement. So this program is just to show you that since the manipulation has been done in this case with x and y, which are actually the past values of the main function as A and B, and after manipulate call, do we see a change in A and B as well? So I'll compile the code as call by address2.c, and then we will execute and see. The value of A and B is 30 and 10 as the first statement. Thereafter, we make a call to manipulate function. What manipulate does is it will give us the new value of x, which is x divided by y, and new value of y as whatever is the value of x here, that is multiplied with y. So the new value that we get over here is 3 and 30. How did we get that? Because we have divided x by y. हमारा x का value क्या था? It was 30, and y का value हमारा 10 पास होता, because a गया था x को, b गया था y को. So 30 divided by 10, we got 3 over here, and then I multiplied x into y. X was 3, y is still 10 with us. So 3 into 10, 30 is stored in y, and that information we are able to get through A and B. Why is it so? because now it is not just A and B which is holding the information at some memory space. It is also X and Y which is holding the same memory information space. For example, in this case, I believe it has already been taught, but still it is crucial to function, so I'm again discussing. We have a variable A over here, we have a variable B over here, which has got some memory address. It is storing some value 5, let's say. It is storing some value, let's say 3 in this case. Now I have passed the address of A and the address of B to X and Y respectively. I can say that these are pointers with the asterisk notation. And now since I've passed the information of the address, X has the access to A's memory location, Y has the access to B's memory location. Whenever I make changes, even through X in this memory space, it means that same change will also be reflected in A's call. That same change, if I make in Y, that same change will also be reflected in B's call. So this is what is happening over here. We are making changes in X and Y in manipulate function, but that is also visible to us in the form of A and B over here. So that is the reason when I print again the value of A and B after manipulate call, I can get the values which are actually manipulated by X and Y. Okay, so far so good. I think everyone is able to follow properly. Abhijit, things are going good?
Yes, sir. Sir, I think Pratik had a doubt, so he's writing it down in the comment section.
Okay, fine. Okay, I'll just want to see how much. Okay, we are not very. Okay, we are close to completion. Not much of the things are remaining, but very crucial things they are. So, is it a good time to break, or if everyone is okay, we can take another 10 minutes and move on to the next topic?
Sir, anything is fine.
Okay, just want to know something from the audience side. If anyone is commenting, or I'll continue.
So there are no comments as of now, so I think we can continue for next 10 minutes and then take a break.
Okay, I'll take the next part, that is arrays in function, how we can pass arrays in function. Okay, Pratik says, can we say in call by value, the variables are local to that function? Yes, Pratik, when you actually say call by value, it is just the actual value that you're passing from the actual parameter to the formal parameter. So in that case, what happens is, then in the memory space, we will see some example. Okay, so what happens is, if I'm passing the value of A and B through the function, oh sorry, I did not share the screen. Okay, Pratik, what is happening over here is, we are passing the variable A and B to the function sum through this call. We are passing the values 5 and 7. So those are given to integer A and B. Now, whatever the integer A and B is subjected to inside this function, that changes will not be reflected inside the main function from where these variables actually originated, because we are simply passing on the value. We have not given them the memory location to make manipulation. It is similar to something that you order something from a kitchen, let's say from a restaurant. You have been given the food, okay, but in case if you have been given the access to the kitchen of the restaurant, so over there, if you wish, you may manipulate the things over there. For example, the let's say the texture of let's say you're making something, let's say you're making tea, my favorite beverage. So if you're making tea, the quality of milk that they are using may be heavy to you. For example, they are using buffalo milk. Now you wish to dilute that, you may add some water to it. Now if you've already made changes to the milk that is there in the kitchen, that only the kitchen people had the access as the main function. Now since you have changed the properties of that milk by adding more water to it, now it is not as thick as it was. So that same milk property is accessible to you as well as to the main owner. So even after you leave the kitchen, the person who is the owner of the kitchen will be using that same milk which has been diluted by you, because you had the access to the address of the kitchen. You had the access as the rights to the kitchen. In case you did not have the rights to the kitchen, whichever quality of milk was given to you to make your tea, or whichever quality of tea was given to you, you had to consume it. You could make manipulations to it for yourself. You could add something to it, but that would not mean that those same changes have been reflected in the kitchen thing as well. So I hope this thing makes clear. The information is clear to you.
Sir, hello, sir.
Yeah.
Sir, my point is, suppose in the function we declaring two variables. There are two boxes A and B, and it contains two numbers 3 and 4. And as you said, if we call the function by reference, then it will swap. But if we call by value, then it wouldn't, because the parameters are local to that function.
Right.
So how computer knows that? Means the parameters are destroyed after the execution of function.
The parameters of let me just explain this thing. I believe you want to know how will a computer know when to keep the variables, when to not keep the variables.
Yes.
Okay. So what happens in a typical memory environment is that we have this box. Just give me a minute, I'm not good with it. Assume this is the part where you write your code. Okay, this is the box where you write your code. Now this is the space. This I can call it as a stack. I can call it as a stack space. Now what this will store is, it will store the information of the variables. It will reserve the space in the memory. This entire thing is actually main memory. So this entire thing is main memory, in which we have a code section, a stack section. So this stack section, what it will do is, if inside my main function, if there is a main function as well as let's say an add function over here inside the code section, the stack memory will create variable space for both of them. So what it will do is, let's say I've created a variable A and B. Now this variable A and B have been given some memory space inside this stack space. So that A and B, let's say it are related with the main function. A and B are related with the main function. Now I'm passing this A and B as an argument to add functions parameters. Now this add functions parameter will create a separate space inside the stack. It's inside the stack only. So let's say this is also a portion of stack. It will not create a different stack, but inside the stack memory, it will create a separate partition for it. Okay. So it is creating a separate partition for itself. In this case, what will happen is, the value of A and B are being passed to some variable, let's say X and Y. So X and Y are again getting some memory space reserved for them. Some value is directly passed as 5 or 7 to X and Y respectively. Now let's say it is doing some manipulation, or let's say we also have a variable, let's say C in this case. We also have a variable C in this case, and C at the moment is not holding anything. X and Y are holding information in a separate space inside the stack window only, and A has given a value to X, and B has given a direct value to Y. They have not given the address. Now there is also a variable, let's say in this case, where we let's say it is Z, and Z is actually storing the addition of X and Y. Once the task for the Z is done and the function is about to end, it is about to return some value. Now that value is actually returned to something, let's say Z, and this value we are able to print it with C variable. We are storing the value inside the C variable, because C variable was actually holding the call for this function add. So now since C has got the values from Z, the manipulation has been done inside the add function. So the memory space that was separately reserved for this has been destroyed inside the stack space. So now the main memory only contains the information for the variable A and the information for the variable B, because they are actually the owners of the information, that is 5 and 7. 5 and 7, because we only pass the values to them. In case if I had passed the address, of A and B, in that case X and Y will continue to have the same right as that of A and B, because even they will act as the owner. So they will continue to have the memory with them. So it depends what is the requirement. When we want to protect the information, we simply want to pass the value, but we want to protect the information. We do not want to give the rights. In that case, we will not pass it as an address. We will only pass it as a value. In a case where we want both the parties, the main function as well as the other function, that is add, to have the right over the variable, we will pass it as the address. So in that case, the memory space will be reserved for them. It will continue to reserve because both of them have the access.
And sir, what is the use of static, that it destroys the function after the execution?
Sorry?
What is the use of static?
The use of static. See, in which reference do you want to understand the static function?
Like in main function, we are calling a function, and in the function declaration, we are performing the operations. We add static before the function. Static function a comma b.
Okay. So then, see, in that case, in that case, we do not want any manipulations to happen. In that case, we do not want any manipulation to happen. So that is the reason when we declare a function as static, we want it to be, something as which value should not be accessed by some other function and manipulated for any cause. So that should have some exclusive rights. So let's say in a static function, you can take an application, a banking application, where some entities you do not want to be manipulated. For example, the balance part, that can be manipulated based on the transaction. There is some information which you do not want to manipulate. For example, the number of users which have access to that account, or let's say the account details which do not have to be changed, which can only be passed, but they cannot be manipulated. So in that case, you will define that function as static. Okay. You're understanding a case where you want to give the freedom that the function properties or the variable members can be manipulated by others if they have got the address features. But in a case where I do not want them to be manipulated, I'll keep it as static.
Okay, got it, sir.
Fine. Okay.